Validating documents with schemas. Upon successful completion of this lesson, students should be able to compare schemas and DTDs, explore different schema vocabularies, declare simple type elements and attributes, declare complex type elements, apply a schema to an instance document, work with XML schema data types, derive new data types for text strings, numeric values, and dates, create data types for pattern data using regular expressions. The limits of DTDs. DTDs are commonly used for validation. One complaint about DTDs is their lack of data types. DTDs also do not recognize namespaces. DTDs employ a syntax called Extended Backus-Naur Form, EBNF. A schema is an XML document that contains validation rules for an XML vocabulary. Schema vocabularies. No single standard. A schema vocabulary is simply an XML vocabulary. Support for a particular schema depends solely on the XML parser being used for validation. Starting a schema file. A schema is always placed in an external XML file. XML schema file names end with the .xsd file extension. The root element in any XML schema document is the schema element. The general structure of an XML schema file. The usual form of an XML schema document. Understanding simple and complex types. XML schema supports two types of content, simple and complex. A simple type contains only text and no nested elements. Defining a simple type element. An element is defined in XML schema using the following tag. Data types. The data type can be one of XML schema's built-in data types defined by the schema author, or user data type. Here is an example. Another popular data type in XML schema is decimal. Defining a simple type element. Defining an attribute. The default and fixed attributes are optional. Defining a complex type element. The basic structure for defining a complex type element with XML schema. Referencing an element or attribute definition XML schema allows for a great deal of flexibility in writing complex types. Rather than repeating that earlier attribute's declaration, you could create a reference to it. Defining an element with nested children. Complex elements that contain nested child elements but no attributes or text. The following compositors are supported: sequence, choice, all. Defining an element containing nested elements and attributes, the code for a complex type element that contains both child elements and attributes. Specifying mixed content. An element is said to have mixed content when it contains both a text string and child elements. Indicating required attributes. Uses one of the following three values: required, optional, prohibited. Here is an example. Specifying the number of child elements. To specify the number of times an element appears in the instance document. Validating the schema document. Applying a schema to an instance document. To declare the XML schema instance namespace. You add a second attribute to the root element to specify the location. XML schema divides its built-in data types into two classes, primitive and derived. A primitive data type, also called a base type. A derived data type is one of 25 data types that are developed from one of the base types: string data types, numeric data types, date and time data types. Deriving customized data types. The code to derive a new data type is here. This structure is also known as a named simple type. The following three components are involved in deriving any new data type: value space, lexical space, facets. New data types are created by manipulating the properties of value space, lexical space, and facets. It can be done by 1. Creating a list based on pre-existing data types, 2. Creating a union of one or more of the pre-existing data types, 3. Restricting the values of a pre-existing data type. Deriving a list data type. A list data type is a list of values separated by white space, in which each item in the list is derived from an established data type. The syntax for deriving a customized list data type is here. Deriving a union data type. A union data type is based on the value and/or lexical spaces from two or more pre-existing data types. Each base data type is known as a member data type. XML schema also allows unions to be created from nested simple types. The syntax is here, where rules 1, rules 2, etc. are rules for creating different user-derived data types. Deriving a restricted data type. Constraining facets. Constraining facets are applied to a base type using the structure here. Deriving data types using regular expressions. A regular expression is a text string that defines a character pattern. Regular expressions can be created to define patterns for many types of data, including phone numbers, postal address codes, and email addresses. To apply a regular expression in a data type, you create the simple type here, where regx is a regular expression pattern. Here is an example. Regular expression character types. The general form of the character type is here. Common regular expression character sets. Characters can also be grouped into lists called character sets that specify exactly what characters or ranges of characters are allowed in the pattern. The syntax of a character set is here. Regular expression qualifiers, to specify the number of occurrences for a particular character.